Countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh, and good evening teachers, parents and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our session by reciting Umul Kitab for Muslim, and for non-Muslim, please pray according to your own religion. Let me introduce myself. I'm Cikgu Shahnon from Penang Matriculation College, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So, are you ready? Let me introduce our teacher for today's lesson. We have teacher Vivi Lau from SMK Tinggi Klang. We are now live on teacher Vivi Lau channel. Please support her channel by clicking subscribe now. And the topic for today's lesson is Louis structure part 2. And together with us, we also have teacher Tang from Selangor Matriculation College, who is control host, in charge ensure the smoothness of our lesson and technical support. And the last but not least, teacher Kong from Perak Matriculation College as an observer. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat section wisely. Number 2, regarding a certificate link, the link will be given at the end of our lesson. Please use EDD, MOE, My Guru, and My Jawi account when you fill in your particulars. Make sure you fill in the form within the time limit, which is 30 minutes. Okay, especially for a student, I announced the passcode for AYU credit. For your information, the passcode will be announced 3 times, at the beginning, in the middle, and at the end of the broadcast. The first passcode, letter A and number 7. I repeat, letter A and number 7. So without further ado, teacher Vivi Lau is welcome to present the Louis structure part 2.
Okay, good afternoon, teachers and students. Thank you, Cikgu Shannon and teacher Kong and also teacher Tang for joining me today. So today I will continue teacher Kong's lesson last week on Louis structure. Okay, so first I will introduce myself. I'm teacher Lau, Vivi Lau, my channel, YouTube channel. Then my name is Lau Chai Wee. I'm currently teaching in Pusat Tingkatan 6 SMK Tinggi Klang. Okay, so these are my PU teammate. So first we have mathematics team. We have teacher Im, who is the Ketua Panitia, and we have the other teachers, teacher Eileen and teacher Zainaria. Okay, next we have bio team, which is led by Cikgu Faiza. Okay, and physics team led by Madam Rosmaya, and economy and accounts led by Madam Fizi. Okay, last but not least, we have chemistry, which is led by Cikgu Shannon. We also have teacher Tang, Cikgu Mawa, and teacher Kong here. Okay, so the learning outcomes for today is we have to know how to draw the Lewis structure of covalent molecules and the ions. Okay, so first we look at definition of Lewis structures. So Lewis structure is a representation of covalent bonding in which shared electron pairs are shown either as lines or as pairs of dots between two atoms, and lone pairs are shown as pairs of dots on individual atoms. So only valence electrons are shown in a Lewis structure. Okay, so these are the steps for determining the Lewis structure of the covalent molecules. So step 1, determine the central atom. Step 2, determine the total number of valence electrons available. Step 3, draw a single bond from each surrounding atom to the central atom. Step 4, distribute the remaining valence electrons in pairs to fill each atom's octet. Step 5, complete the central atom octet with multiple bonds. If the molecule have multiple bonds, okay. If not, you use a lone pair, so depend on the example. Okay, so for step 1, you also have to see whether it's a neutral molecule or a charged molecule. So neutral molecules, the total electrons just equal to the valence electron of the atoms. Then if if it's a molecular ion, let's say positive charge, the total numbers must be subtracted. Okay, let's say 1 positive. Let's say the ion is 1 positive, you have to subtract by 1. However, if it's a negatively charged ion, then you have to add electrons. Let's say if negative 2 charge, then you have to add 2 electrons. So we look at the first the example. So you have to roll this molecular ion, carbonic ion. So first you have to determine the central atom. So carbon is a less electronegative atom than oxygen. So carbon is a central atom, or you can just look at the formula. Central atom usually only 1 atom. So carbon is only 1, surrounded by 3 oxygen. So carbon is a central atom. Then second, you calculate the total number of electrons, valence electrons. So carbon is group 14. So carbon has 4 electrons. Then oxygen is group 16, so 6 electrons. So 6 electrons. Okay, carbon group 14, 4 valence electron. Oxygen 6 valence electron. So you have 3 oxygen. So 3 times 6, so 18. Okay, so 4 plus 18 plus 2 from the negative charge. So altogether you have 24 valence electrons. Okay, step 3, draw the single bond from the surrounding atom to the central atom. So you join the central atom and the surrounding atoms. Okay, so 1 covalent bond, single covalent bond is 2 electrons. So you have 3 covalent bond here, so 6 electrons. So minus the 24, minus with 24, so you have 18 electrons remaining. Okay, then step 4, you distribute the remaining electrons as the lone pair electrons to the surrounding atoms. So oxygen must be octet, must obey the octet. Okay, so you must have 8. Okay, so you got ignore the charge first. Okay, so you have 8 times. Okay, 3 bonding pair just now, right? 3 times 2. Okay, then lone pair is 2. So 9 got 9 lone pairs here. So 9 times 2. So 6 plus 18. So you got 24 electrons. Sorry. So you will use up all the 24. Okay. So we look at step 5 because carbon not yet octet. Okay, carbon not octet. So carbon must obey the octet. So you have to move the electrons from the surrounding atom. So you move the 2 electrons from the 1 oxygen atom to the carbon. So you will have one double bond. Okay. So now oxygen and carbons are all follow the octet theory. Okay. So the label the negative charge for the electron from the negative charge. Okay. So we have 2 electrons for the negative charge. So you have to label the negative. Okay. So you have to show Lewis structure where the charge are shown at the atom. So you don't use a bracket one. Don't write this one. Don't write this one. Means you show bracket. Then the charge outside. Okay. So the examiner wants you to show the negative charge at the atom. So you don't write this one. Okay. So this one I erase. So this is Lewis structure. So Lewis structure must show all the valence electron, then all dots. Don't have cross. Okay. So these are the steps to determine the Lewis structure. Okay. Next we look at Lewis structure of covalent molecules. So you have to know the molecules that obey octet rule. For example, we have ammonia, CCl4, H2O, carbon dioxide, N2O4. Okay, they are all follow the octet rules. Okay, so you can see that all the nitrogen, carbon, oxygen, they must obey the octet. Okay, then we have exception to the octet rule. Okay, example, we have BF3, NO, NO2, PCl5, and SF6. This one exception to the octet rule. Means they don't follow octet. So we see the Lewis structure for each. Okay, so first we have ammonia. Okay, so ammonia, you know the nitrogen is group 15, right? So nitrogen must have 5 valence electron. Okay, so total, you count the total valence electron ammonia. Example for the count the total electron. So nitrogen 5 electron, hydrogen we have 3 here. Like hydrogen is 1 valence electron, so 3 hydrogen. So 3 times 1, so 3 electrons. So total is 8. 8 electron. So you roll the nitrogen first, then roll the surrounding hydrogen. Okay, so roll the bonds. Okay, so 2, 4, 6. Then the lone pair at the central atom. Okay, so very easy for the ammonia. Next one, we look at the CCl4. So CCl4 carbon is a central atom. Okay, carbon 4 electrons. Okay, chlorine is group 17 and 7 electrons. So we have 4 chlorine here, so 21. So altogether we have 28. Altogether we have 32 electrons total. So total we have 32 electrons. Okay, so roll the surrounding atom, surround the carbon, so 4. Okay, so 4 covalent bonds, so 2 times 4, 8. 8, then you get 24. Okay, so distribute the electrons as a lone pair. So 1 chlorine atom, 3 lone pairs electrons, so 3 times 2, 6, right? 6 times 4, 24. Okay, so you use up all the 32 electrons already. Okay, so very easy. Okay, next we look at water. Okay, so water, the central atom is oxygen. Okay, so oxygen 6 valence electron, oxygen central atom, 6 valence electron, hydrogen 2, so 2 hydrogen, so 2 electron, so all together 8. So 2 covalent bonding 4, so another 4 is a lone pair. Okay, next we have carbon dioxide. Okay, carbon 4 valence electron. Okay, carbon 4 valence electron. So oxygen we have 2, so 6 valence electron, 2 times 6, so 12. Okay, so we have 16, total 16 electron. Okay, so roll the oxygen surrounding the carbon. Okay, then at first you roll 6 single bond. Okay. Then you distribute the valence electron. So oxygen 6, so distribute. So just now 4 electrons from the covalent bond, right? 16 minus 4 is 12. So one, this one single bond first. Okay, so one oxygen 6 valence electron. Okay, 6 times 2, so 12. Okay, so you use up all. Okay, but the carbon not octet. Okay, so you must bring the lone pair electron inside. Bring the lone pair electron inside. Okay, so you got, bring inside, so that the carbon rubber bond. Okay, because the oxygen must have octet also lah, so you cannot bring in as a lone pair lah, must bring in as a rubber bond. Okay, so oxygen add octet, follow octet, the carbon also follow octet lah. So this is how you roll the carbon dioxide. Okay, so if you were used to the calculation, right, you no need to show total electron, also cannot straight away wrong. Okay, so now we have N2O4. Okay, N2O4 you can roll like this and show the lone pair electrons as a coordinate bond from the nitrogen. Okay, by arrow, or you can just roll the line. Okay, this one or this one also can. So so the nitrogen follow octet, oxygen also follow octet. Okay, so this one is from the nitrogen dioxide. That's why it form this structure. Okay, the nitrogen dioxide has odd electron at the nitrogen. Later we will see. Okay, so that's why it will tend to form this structure. Okay, to form the N2O4. Two nitrogen dioxide combine. Okay, because of the odd electron not stable, will form this one. That's why you form this structure. Okay, so now we look at the example of molecules that does not obey the octet rules. Okay, so we have boron trifluoride first. So BF3, the boron only have 6 electrons. Okay, the next one is just now the that one is NO2, this one is NO. Nitrogen monoxide, you have 1 odd electron also. Okay, then the next one is NO2 like just now. Okay, so got 1 odd electron, so it's not follow the octet. So altogether 7 electrons, like 1. So it will tend to form the N2O4 just now. Okay, so it will 2 will join together and form the stable N2O4. Okay, this one will form this one. Okay, NO2 you also can show the arrow. Okay, for the coordinate bond. Okay, nitrogen has 1 lone pair electron share to the oxygen. Okay, so that's why the formal charge of nitrogen is positive here and negative at the oxygen. Okay, this one show the formal charge. Okay, another exception is PCl5. So the phosphorus can expand the octet. So it can have more than 8 electrons. Another one is sulfur hexafluoride. So it's 12 electrons surrounding the sulfur atoms. Okay. Then the Lewis structures for the polyatomic ions, you also have to know. So just now we have discussed carbonate ion. So we look at the other 3. Okay, so we have sulfate ion. So same like just now, you count the total valence electron. Only you can roll the Lewis structures. Okay, unless you're very used to it, you don't need to count also can. So for the sulfur is group 16, so got 6 valence electron. Then oxygen, we have 4 oxygen. So 4 times 6, so 24. So total we have 30 electrons. Okay, So first you roll the oxygen surrounding the sulfur, okay? Then roll the bonds. Okay, at first you roll single bond. Okay, roll the single bond first. Like just now. Okay, then you add the lone pair electrons. So here got 4 bonds, 4 times 2, 8 electrons. So 30 minus 8, you have 22. Okay. Okay, you distribute the lone pair electrons to the oxygen. Okay, so 6 times 4, 24. Okay, so just now I forgot to add electron from the charge. Okay, 2 negative, right? So plus 2 electron from the charge. Negative charge. So total you have 32 electrons. Okay, 32. So here at 24. So all used up already. But sulfur can expand octet. Okay, sulfur can expand octet. So one lone pair will go to the inside. Okay. Later we will learn formal charge why you have to write this one. So the base structure is we have lone pair electron go inside as a double bond because sulfur can expand octet. Okay. So you have 2 double bond and 2 single bond. Okay. So later we will discuss why we must have double bond. You have to use a formal charge to explain. Okay. So we look at the next one. Next one is this one just now discussed already. Okay, nitrate ion. Okay. Then 1 double bond and 1 single covalent bond. So here also show the formal charge inside. Nitrogen is a positive one. Here 2 oxygen have negative one. Okay, then last one cyanide ion. So cyanide ion, when you roll the Lewis structure, you have to make sure the negative charge go to the carbon. Okay. Okay, so we look at formal charge. Okay, so formal charge is not the real charge. It's a charge, imaginative charge or apparent charge assigned to the bonded atoms in the Lewis structure. Okay, is to help you to decide the best Lewis structure. Okay, so first you have to look at the types of electron pair. So we have lone pair of electrons. Lone pair of electrons means the electrons just belong to the atom, okay, not shared. Then bonding pair electrons means the electrons are shared between 2 atoms, shared equally. Okay, so lone pair electrons and bonding pair electrons. Okay, so this is a formula for formal charge. So formal charge is number of valence electron minus number of valence electron minus the total of number of lone pair electrons plus half the bonding pair electrons. Bonding pair electrons is half because share equally between 2 atoms, so you have to divide by 2. Okay, so example we look at neutral one. We have different calculation for charged ions. Okay. The formula is the same, but for the determination of the base formal charge is different. Okay. So for the neutral molecules, they must be 0. The sum must be 0. Okay. Then for the charged one, the sum of formal charge the base one should be equal to the charge of the ions. Okay. So for neutral molecules should be 0. So this is a base Lewis structure because you look at the phosphorus. Okay, so phosphorus is group 15, so it has 5 valence electron. 5 valence electron minus, so it has 1 lone pair electrons. So 1 lone pair got 2 electrons. So 2 plus, okay, bonding pair electrons. So bonding pair electrons is 2, 4, 6, 2 or 3 bonding pair. So must share between the chlorine and phosphorus. So you have to divide by 2. So 2 plus 3, 5. So 5 minus 5 is equal to 0. Okay. Then we have chlorine. We have A, B, C. So we have to count for all the 3. So all the 3 are the same. Okay. So chlorine is good 17. So 7 valence electron. So 7 minus. Okay. So it has 3 lone pair. So 6 electrons. 6 plus 1 bonding pair. So 1 bonding pair 2 electrons. So divide by 2. So you get 1. So 6 plus 1 7. So 7 minus 7 0. Okay. So total formal charge is 0. So this is a base Lewis structure for PCl3. Okay, then we look at the negative charge ion. Okay, so for the carbon 4 minus, no lone pair. So 0 plus half got 3 bonding pair, but 1 is double bond. Okay, so 1/2 divided by 8 divided by 2. So you have 4 minus 4 0. Okay, so then oxygen you have A, B, C. So A and B calculation are the same. So 6 minus 6 plus half 2 got 1 bonding pair. Okay, so negative 1. Okay, then got double bond for the C. So half times 4. Okay, so 2 plus 4, 2 lone pair. So 4 here. So 6 minus 6 0. Okay, so you have total formal charge negative 2. Okay, so this is a base from Lewis structure for carbonate ion. Okay, then we look at last one example for formal charge, positive ion. So ICl2 plus. So the iodine is group 17. So 7 valence electron minus. So here got 2 lone pair. So 4 plus 2 bonding pair. So 4, each one 2 and 2 plus 2, 4. 4 divided by 2, share with 2 chlorine atoms. Okay. So you will have positive 1. Okay. Then Cl, A and B, same calculation. So 7 minus 6 lone pairs plus bonding pair 2. So 1. Okay. So you will get 7 minus 7, 0. Okay. So total you will get positive 1. Okay. So it's equal to the charge of the ion, the formal charge. So this is a base Lewis structure. Okay. So far, any question?
No question yet.
Okay. So I
Maybe
continue.
you can continue.
Okay. So determine the most possible Lewis structures. So if why we have to use calculate the formal charge, because sometimes we have many possible Lewis structures. That's why we have to find the formal charge. So this one is summary for just now. So for neutral molecules should have no formal charge, 0 formal charge. So for the polyatomic ions, you should get smallest formal charge. Okay. Sometimes you cannot get equal to the charge of the ion. So you have to try to calculate, try to write the Lewis structure that have the smallest formal charge, okay, lowest formal charge value. Then for the negative formal charge must put at the electronegative atom, okay. So electronegative atom is at the right side of the periodic table. So for example, oxygen, fluorine, they must have negative charge, okay. So if you get negative, should put the negative at the more electronegative atoms. Okay. For example, oxygen, chlorine, nitrogen. Okay. So now question. So you try to roll the Lewis structure for these 3. So we have neutral molecule and sulfur trioxide, and the phosphate ion, negative charge ions, and positive charge ion, ammonium ion. So you can enter this one. Okay.
Teacher Vivi Lau, maybe
Yeah.
we can stop for a while for advertisement, and we will
Okay. So
uh,
collect the answer. Okay. So you go to the classpoint.app, enter the code, and draw on the slide. Okay. Okay. So Ibu channel, you can go to advertisement.
Tuisyen online percuma. Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okay, student, you can go to the classpoint.app now. Then enter the class code 59296. Then you can just roll on the slide. Okay, so maybe you cannot see the question. I minimize for one. Okay, so the question SO3 phosphate PO4 3 negative and H4 plus. So I give you 5 more minutes to roll it. Okay, here I see one response. What answer? Okay, it's okay. So that's wrong. I forgot. Okay, so here we can see the student answer, but I forgot I have to remove the answer first. Okay, so I stop correcting response. Okay, so we look at this answer from the student. So here, this one is the answer. My answer, I forgot to hide the answer. Okay, so so like I told you just now, you have to draw the charge inside. Okay, like my answer, the charge must go inside. Okay, so I show you the answer. Okay, where is it? Here. Okay, this one. Okay, so this one the answer. So you must show the charge inside. Okay, so must write the charge inside. So got 3 negative. So you show all the 3 negative inside. Okay, then the ammonium ion, the positive must be inside. Okay. Okay, so we can try calculate the formal charge. So so the formula is like this. If you forgot the formula, so number of valence electron minus the lone pair electron plus half the bonding pair electrons. Okay, so count like this. 2, 4, half, 2, 4, 6. So 6 minus 6 or 0 for the sulfur. So 2, 4, 2, 6. So 0. So 0 also formal charge. So 0, 0, 0. So this is the most possible restructure because total is 0. Total formal charge 0 equal to the neutral molecule. Okay, then this one 2, 4, 6. Okay, oxygen is 6 valence electron, so 0 for this one. So 2, 4, 6, 7. So 6 minus 7, so negative 1. Okay, so this one same like this one. So 3 negative, so equal to the, I forgot to count phosphorus. 2, 1, 2, 3. Okay, 5. So 5 minus 5, 0. So total formal charge is negative 3. So it's equal to the charge of the ion. Okay, then this one, hydrogen 0. Okay, all 0. 1 minus 1. Okay, so nitrogen is 5 minus 4. So here 1, 2, 3, 4. 5, group 15 nitrogen. So the formal charge is positive. Okay, so your positive must roll at the nitrogen. Okay, so you remember this one. So the structure also is the best restructure. Okay, any question for the restructure here? No question. Okay, so this is your answer just now. So must draw the charge inside.
Yeah, no question.
Okay, now another question. Okay, so the image no clear. Okay, so this one you just type in the chat box. What is the preferred Lewis structure for NCO negative ion, considering the formal charge? From this 5, you choose the best one. So you type your answer in the chat box using the formal charge.
Teacher Vivi Lau, maybe you can give a clue how to write clue. How
The
to
formal
write the
charge.
formal charge.
Okay, so I give you the formula again. Formal charge formula. Okay, so the valence electron minus the long pair electrons plus the half the morning pair electrons. Half the morning pair electrons. Okay. So let's say I show you this one. So this one, nitrogen, the valence electron is 5, group 15. So 5 minus, okay, so you got 2 lone pair, so 4, 4 plus half bonding pair got 4 here because double bond, okay. Okay, so nitrogen here got 2 plus 4, 6, 5 minus 6 is -1. So nitrogen you got is -1 here. Okay. So you have to calculate for all the atoms inside the Lewis structure. So carbon here is group 14, 4 minus 4, no long pair, 4 minus 2. Sorry, this one got 2, 4, 6, 8. Okay, 8 divided by 2, 4, 4 minus 4, 0. Okay, then this one is 6 minus, got 6 long pair, 6 long pair, 6 plus 2 here, 8, so -2. Okay, because this one is 6 minus 6 plus half 4. Okay, so 2 plus 6, 8. So 6 minus 8, -2 for oxygen. So you do like this. So carbon is 4 minus, no lone pair, 0 lone pair. So 2 rubber bonds, okay, so 8. 2 rubber bonds is 8, it's 2, 4, 6, 8, divided by 2, 4. So 4 minus 4, 0. Okay, so you do for all the. So this one total formal charge is, for number 5, total number charge is just now -1 plus 0 plus -2, so you got -3. Okay, so this is not a good, this one is not good. This one cannot be the answer because the formal charge value too high. Okay, and different from the charge of the ion. The charge of the ion is -1. So you try to calculate for the others Lewis structures.
Okay, student, you can try. You can try question number 1, number 2, number 3, and number 4.
You try for the other Lewis structures. So the preferred one should be the one with the lowest, because this one is not neutral molecule. Lowest formal charge will be the preferred one. The base is equal to the charge of the ion. Okay.
We're still waiting. Student answer. And for your information, students, question number 4, if you look at the structure, the carbon over there is not octet, right? Carbon is not octet.
Okay.
So actually we can eliminate the question number 4
Okay,
as
so we eliminate.
preferred restructure. Okay, but you have to write the formal charge. Okay, you have to write the formal charge as question number 5. Okay, question number 5 actually the oxygen there. If you look at oxygen, it has more than 8 electron.
Also cannot.
4, 5, 6, 10, right?
No,
10. So, okay, that's why when we total up the charge there, not equal to the -1. Okay. But for question number 1, number 2, and number 3, I can see that it's a follow octet, but we have to find the most, we call it plausible restructure. Okay, student, still no attempt from student. Question number 1, question number 2, and question number 3, and also number 4. You have to write the formal charge, but you can choose, I think, number 1, number 2, and number 3. Number 1, number 2, and 3, you have to choose the preferred Lewis structure. Okay? You still waiting?
Because number 1, 2, 3 follow octet. So this one not follow octet. This one also.
Our student quite shy. You can see that. They're quite shy. Okay.
It's okay. It's okay to be wrong, student. Just try.
How many times you want to?
It's okay.
Student.
Okay, I give you one more minute.
All because of their line, and their line not stable, cannot write anything on the chat box. Many possibility. Okay. Shy, line problem. All right.
Okay, so 21 minutes up, right?
Still no answer from student.
No answer.
I think,
okay, so
you can continue. You can continue.
So I continue. So the best one is number 1. Okay, number 1 is the answer. So you can see this one nitrogen is 1, 2, 3, 4, 5. Okay, so 5 minus 5 0. Put 59. So this one 1, 2, 3, 4. So 0 also. 2, 4, 6, 7. So negative 1. So it's a negative 1 charge. So same as the charge of the ion. We look at this one 2, 4, 6. So this one is this one negative 1. Okay, so cannot be 2, 4, 2, 4. Okay, so 0, 2, 4, 6. So 0. Okay, so the negative must go to the more electronegative. Oxygen more electronegative than nitrogen. So should be oxygen get the negative. So this one wrong. Okay, so this one 2, 4, 6, 7. Okay, so 7. So negative 1. Okay, 2, 4, 6. This one negative 2. Okay, negative 2. So too high the formal charge. This one 1, 2, 3, 4, 0. 2, 1, 2, 3, 5. So this one is positive 1. Okay, so it's not good. Okay, oxygen get a positive. So the best one is number 1. You can see the formal charge is negative 1 total formal charge, and the negative at the oxygen atom, and the formal charge value same as the charge of the ion. Okay, so we look at the exception. Exception to the octet rule, we have 3 types. Incomplete octet, expanded octet, and odd number of electrons. Okay, so incomplete octet means the electrons surrounding the central is less than 8. Okay, so for example, we have boron, barium, aluminium. So they will have barium only 2. Okay, 4 means 4 valence electron, 2 covalent bond, 3 covalent for boron, so 6. Aluminium here also 6. So all not octet. Okay, then we have expanded octet. So expanded octet is the surrounding the central, we have more than 8. So this is happen for the element at period 3 and beyond. Okay, so they can expand their valence cell. Sorry, this one wrong valence shell. Okay, due to the existence of empty d orbitals. Okay, so empty d orbitals. So example, we have like just now, PCl5 phosphorus pentachloride. Okay, so you've got 10 electrons at the phosphorus, and sulfur hexafluoride, we have 12 electrons at the sulfur. Okay, so expanded octet. Then last one, we have odd number electrons. So the atom has a odd number. This one 2, 4, 5. 5 means 7 valence electron. 2, 4, 6, 7. 7 electron here. Okay, so means not octet and have odd number, one electron odd number. Okay, so this one is the last topic for today. Concept of resonance. Okay, so resonance structures definition. Two or more Lewis structures which can be written for a single molecule, but no one structure can accurately represent the actual structure. So resonance structure, it means you write out all the possible structures, possible Lewis structure for the molecules. Okay, characteristics of the resonance structures. They have some relative placements of atoms, but differ in the distribution of valence electrons. Okay, so means the long pair, bonding pair electrons, they will be localized. All chemical bonds in the resonance structures have same length and same strength. Okay, the bond length of chemical bonds in the resonance structures is an intermediate between the single and double bond. Okay, so we look at this one. Okay, so you can see the lone pair can shift. Okay, and the bonding pair also can shift. So example of resonance structure of NO2 negative ion. So the lone pair electron can shift inside here, so from the double bond. Then the double bond here, the electron can shift to the oxygen atom here. So the negative charge also move. So you can write like this. Okay, so this is a resonance structures of the NO2 negative ion. So it's represented by this one, this symbol. When you roll the resonance structures, when the question asks you to write the resonance structures for the species, you have to roll this one. Okay. Then another example is the resonance structure of phosphate ion. So you can see the lone pair electron shift. Okay, so this one shift inside here. Okay, shift inside here. So from the double bond. Okay. So this one will shift out. Okay. So electron go here. So negative charge go here. Then this one shift again. Okay, this one shift over here. Okay, so from the double bond. So this one will shift out. Then from this one. Okay. Then this one is here. This one shift inside. Then this one shift out. Okay. So you can just, when you roll, you just move the double bond. Okay. And roll the reversible arrow. Okay. Next example has CO2 negative ion. Okay. Same thing. You just shift the double bond and the lone pair electrons. Okay. And the resonance structure of SO3. Okay. So this is a resonance hybrid. Okay. So the actual structure, all the three bonds have the equal bond length and bond strength. Okay. Because you know double bond is shorter and stronger, right? Okay. So now all the three sulfur oxygen bond all have the double bond character. So it's very strong. So this one is happen also in the benzene ring. Later you will learn. The benzene ring all have the calculate structure. So the calculate structure can shift. Okay. So it will get this one. Okay, the actual structure of benzene ring is all the rubber bond relocalized, so make the benzene ring very strong. All the carbon bond has rubber bond character. Okay, like shown in this one, means dotted lines here. Okay, so this is a NCO negative. Okay, so normal question will ask, explain why the 3 carbon oxygen bonds in the carbonate ion are of equal length and equal strength. Okay, this is how the question will ask. So you have to answer like this. Because the 3 bonds have the equal length and strength. Okay, because of the resonance. Okay, resonance. So and they have 3 resonance structures, so you have to draw out the 3 resonance structures. Okay, so these 3 resonance structures contribute equally to the actual Lewis structure of the ion. So this is a resonance hybrid. So the actual structure is like this. Means all the 3 carbon oxygen bonds have the carbon rubber bond character, means they have the same bond length and bond strength. Okay, so this is how the question will ask. Okay, so far any question from the students? Cikgu Shannon.
No question from student.
Okay, so
As I mentioned before, maybe they are very shy or line internet problem. Write anything on chat box.
Actually, in the syllabus, don't have formal charge actually for SGPM. Okay, so that's why maybe they not used to formal charge, but we need to know formal charge. I also still teach formal charge because easier for them to roll the Lewis structure. Okay, so the resonance also you need to know, although not in the because later you will understand the structure of the benzene ring. Okay. Okay, so that's all for my lesson today. Thank you very much. Okay. So I go back to Cikgu Shannon.
Alhamdulillah, we are done with today's lesson. We have learned a lot from teacher Vivi Lau about Lewis structure part 2. Congratulations. Okay, to those who are able to follow our lesson from the beginning till the end. And thank you very much, teacher Vivi Lau, for such interesting lesson. Now, it's time for me to announce the last passcode. The passcodes are number 7, number 3, and number 8. I repeat, number 7, number 3, and number 8. And the presenter telegram is t.me/chaiwee99, CHAIWEE 99. Okay, please check the check box for the certificate link. Please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to Teacher Vivi Lau for giving you a free lesson today. Don't forget to click the bell button too, so you won't miss out any new videos and live classes from Teacher Vivi Lau. If you like today's lesson, then please click like and share it to your social media friends. Let's share the knowledge we received today. Sharing is caring, right? When we're finished, type done in the chat session. Once again, I would like to thank to Teacher Vivi Lau for the interesting lesson. Thank you also to Teacher Kong and Teacher Tang for being with us today. And I think that's all for now. See you in another lesson Please do remember, stay at home, stay safe. Goodbye everyone. Have a nice weekend.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.